All right, this assignment will be a little shorter, a little simpler. I want to quickly talk about loops in programming. Okay, so I'm going to say when the green flag is clicked, forever, and that's the most the most basic loop is a repeat, right? This means do this things that many times. So I could play the meow sound, and if you haven't wondered this, it says repeat 10 times, play sound meow. Why did it just play one meow sound? Well, it did play 10, but modern sound cards can fire off several sounds at the same time. So it fired 10 meow sounds simultaneously. If I hit this again, it will keep doing that all 10 times, so I'll hit stop. And that's a repeat loop. Repeat in Python and other programming languages is a little bit more complicated than just saying do this 10 times, but it's also a lot more powerful than Scratch's repeat. Okay, so we're going to talk about other loops. And a loop, why do they call it a loop? Because it is what it sounds like. It's a loop-de-loop, like on a roller coaster. It's a thing that keeps happening. Well, I guess it's not like a roller coaster. Well, roller coasters keep happening. But anyway, it's a block of code that keeps repeating. It's actually one of the few times in programming where you don't keep going top to bottom, down, 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 because it goes back up and repeats everything in that block that amount of times. Okay. Now, forever in Scratch is cool. You can do a lot. We did in a different unit. We did forever if touching lava hurt my health, or if touching apple give me points or something. Because if you just say if, that block only happens once when the green flag is clicked or whenever it's told to. You can see it flashes real quick when I click the green flag, probably. If I put a forever there now, it's running forever checking. Now, in Python and other programming languages, these kinds of forever loops, they actually freeze the program or lock it up. And if you don't know what you're doing, it can cause a crash or just lock everything up until you know how to control, delete, or break into the program and stop it from being frozen. Okay. The cool thing about Scratch we talked about before is it has threading or multi-threading, multitasking. It can do several things at once. So I should just duplicate. I can have several forever ifs, and Scratch just allocates time. It says do this, try this, and it does them all, you know, in a order that we can't predict, which actually can cause problems. It's called race conditions, which we might see later on in Scratch. Basically, if I said if touching lava die and if touching apple win, what if I start the game and the cat's touching both of them, touching the lava and the apple? He can't win and lose. Well, he could if it did something simple, but if he died or disappeared, only one of them would happen, and you won't know which one would happen because you don't know what order Scratch is running these forever ifs in. Anyway, that was a little bit of a sidetrack, but enough people have that problem that I thought I'd mention. Okay, so forever ifs are great in Scratch, not that useful in other languages. Okay, now Scratch also has, these are not loops. If and if else are not loops. They're conditional control structures that branch the program into different actions depending on the conditions, or the true falses or touching, sensing, those kind of things. Not loops. The bottom ones aren't loops, so all we have left is wait until and repeat until. Okay, wait until does just what it sounds like. It means wait until touching lava and then die, or wait until you get the key and then say you won the game, or anything like that. Okay, it just sits there and hovers. If I hit start, it's sitting there waiting for this condition to become true. Okay, so wait until touching the green door or the red lava or whatever. And then once that happens, then it will continue on with the rest of this. Wait untils are not that common in, at least in beginning Python programming. It's, again, like I said, they'll lock up most basic programs. Okay, so we're not going to do wait until. We are going to do a repeat until. Okay, in Python, this will be called a while loop. Repeat until 5 equals 5. Okay, so this will continue. Oh gosh, this is actually weird. This is not a while loop. This is a while not loop. Forever ifs and repeat untils are kind of opposites. Okay, let's talk about it. Let's actually get this making sense. Let's go touching red. Let's get the apple out. You know what? We're tired of apples. Let's do baloncesto, basketball. If touching basketball. Okay. And now the wait until we're not going to talk about, but you could say wait until touching basketball and then do the other stuff. Let's plug this into both of these, and we'll put a meows in there, and we'll put a meow in here. Okay, and let's hook both of these up to the green flag. They can both run at the same time, and let's see what they do. Okay, which one of these is making the meow right now? Forever if touching basketball, then play sound meow. Well, is that condition true or false? That's false, so this cat is not meowing there. Let's actually maybe play a different sound. We'll go, oops. That was for my daughter, not for me. Let's go birthday bells. Oh gosh, stop it. Okay, that's gonna be a lot of forevers. And this one, let's hit play. Do you know which one's gonna play? Is it gonna be the meow or birthday bells? Am I touching the basketball, or am I repeating this until I touch the basketball? Yep. And birthday bells aren't happening because it has a pause at the beginning. Sorry, let's just say something. Is it going to play meow or say hello? He does say hello because I'm not touching the basketball. This condition is false, so repeat until does this until the condition's true, right? So, and the same thing could be achieved by a not. Forever if not touching basketball, then play sound meow. So I'm going to throw away the repeat until because I don't think they're as useful for understanding Python. Okay, I mean they're cool. It's cool that they exist in Scratch, but let's just do forever ifs and let's hit play. Okay, and all this did was switch it, right? Forever if touching basketball, play meow. Well, he's not touching the basketball, so there's no meows. Forever if not touching basketball, play sound meow. When's he gonna? He'll stop meowing when he finally touches the basketball, right? So that hopefully gives you an idea of what's going on. Let's go make a password program. So if today's assignment, or this assignment, is to make a password program that keeps asking them for the right password, okay? So you're going to need to start thinking, well, am I going to have a forever loop that keeps asking them, hey, give me the password, while they have the right password or the wrong password? And just know we could do it either way, right? We could do a repeat until, or a forever if, or forever if not. I'm going to stick with forever ifs in most of my coding because I think it's the most useful, the easiest to understand, okay? So let's throw this away, and let's do it a weird way first. Let's say, hey, what's the password? And then we're going to leave it in the variable answer. We don't need to make a different variable for this one because it's a basic program with one variable. And let's do this. Forever, I want you to pause this, see if you can figure it out. Forever if something, when would we lock them in here? When would we forever lock them in here? If they have the right guess or the wrong guess? And what are we going to do when they're done? Oh, there's nothing after a forever. That's one drawback. Notice that forever doesn't have a tab on the bottom. Repeat until, and wait until they do have tabs on the bottom. So even if this forever is false, it's still going to lock them in the forever. Okay, so that's actually, I didn't think of that. I can't do anything after. So let me do it the way I was planning on doing it. Forever if they have the wrong password. What does the wrong password look like? Well, it means that their guess or their answer does not equal tree. And I'm going to do tree again just so you know it's my go-to password. You can try to hack my email account and see if that's what I use. Don't try to hack my email account. It's probably illegal. So forever if the answer does not equal tree, I'm going to put that not after to have it make more sense. In Python and other languages, there's actually a not right there that you can use that makes more sense. It's more readable. Forever if answer does not equal tree, or not answer equals tree. Let's go run this, and let's just say hello and hit play. What's the password? Bob. Hello, 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 hello. So what happened here? We're stuck in this if, okay? Answer does not equal tree is true. And because of that, we're stuck in this if, this forever if, well, forever. We can't change our answer, okay? It's like having a life, a world with no change and no repentance for the grievances we've caused others, or no way to guess the password again, or to say I'm sorry. So I'm going to say here, instead I'm going to say sorry, and I'm going to ask him what's the password again. I usually Control X, Control V, double click Control V to cut and paste that so I don't have to type it again. Sorry, wrong guess. Let's try this. Does it play? What's the password? Well, it's tree. why did we not, oh, my forever is still running, right? But why is it not doing this? Because this if is false, right? We never get out of that, and that's actually going to cause a problem here. I want to be able to move on with the program and say, welcome, master, thank you for logging in and stuff. So I'm going to have to use a repeat until. Let's go hit play, though, and do the wrong password. Gibberish. Sorry, wrong guess for 2 seconds. And what's the password? And let's go tree and see what happens. Okay, and this loop is still glowing. It's still running. It's still checking to see if I got it right. Even though I did get it right, I should be done. Okay, so forever ifs are not as good as I thought in Scratch. Let's go do a repeat until. Okay, now why did I drag that out again? Let's see if we can throw away the forever and use some of the same stuff. Okay, repeat until. Hey, wait a minute. I like this better. I don't need the not. Repeat until their answer. Sorry, I should have had you do this. Pay no attention to that code behind the curtain. See if you can figure out how to do this with the repeat until. And after the repeat until's done, I want you to say login successful and just some other message. Pretty sure that's Darth Vader that says that. Okay, so repeat until answer equals tree or is not equal tree. And hey, check this out. We don't need an if anymore. We can just, how do I know this works? I mean, I can run it and check, but let's analyze it first. I'm going to put these to the side. Answer equals tree. Okay, well, that right now is true. Repeat until answer equals tree. Well, that's going to repeat the stuff inside here until this thing is true. Let's try it. What's the password? Blah. Sorry, wrong guess. What's the password? Tree. And we got out. Okay, so these loops, I like to think of them as traps. It's a trap. It's a tarp. It's a trap that keeps you in until you get this condition to be false, generally, and then you can leave the loop, okay? And when we start to get a Python, it's important to realize that you can trap yourself in the program forever if you don't let them guess the password again, okay? Now, I want to show you one more thing. Programmers don't like to see the same block of code twice in a row. It's generally sloppy, okay? What I mean by that is I ask a question here and then ask again here. In other languages, there's an easy way to just do this loop first one time. It's called a do-while loop. Python doesn't actually have one, but so I'm going to throw this away and see what can I do. I'm going to hit play. Sorry, wrong guess. Well, that's bad. Okay, it always says sorry, wrong guess, and I didn't even guess yet. Why are you saying sorry? Okay, so that's not going to work. And you say, well, I'll switch the order of these. And what's the password? Well, it's gibberish. And okay, sorry, wrong guess. I fixed it. It works. And if I say tree, what's he going to do? I'm asking right here. It's going to say, sorry, wrong guess, even if I get it right. And then login successful. Okay, so one way to fix that is to put an if right here, right? When would I say, sorry, wrong guess? If their answer was not equal to tree, if it was the wrong guess. That's one way to fix it, okay? So this block, this is the clean one, right? Ask the password. What's the password? What's the password? This is the easiest way to understand it. Gibberish, gibberish, gibberish. I got it wrong. I got it wrong. Tree, I finally got it right. Login successful. But I want a little message that prints if they give the wrong thing, okay? Let me show you the final way that most programmers would do this. If I can set answer to something, and I don't think I can, I can't make answer equal to something. So I'm actually going to use a different variable. I'm going to make a different variable called guess instead of answer. It's the same thing. I'm going to set guess to answer on this line right after I ask. And, oh, sorry, I'm not using answer anymore. I'm going to use guess from now on. Okay, wherever I had answer, I'm going to use guess. And you're like, this is a lot of work, Grammar. Why are you doing it? Because on this line up here, I'm going to set guess to something that's going to force me into the loop. Any ideas what that is? That's going to force me into the loop because it's not tree. If I say guess to tree, we're not ever going to do this. Okay, but if I set it to 0 or blarg or SpongeBob or whatever, SpongeBob does not equal tree, so we are going to go in the loop. And now check this out. I can put, oh, I still can't do this. I still need the if, darn it. I thought I could switch the order around a little bit. Oh gosh, nope, we need that in there still. Okay, sorry, I thought we were making life easier. In Python, you'll do something like this, and you'll like it better. It's gonna, yeah. Anyway, that was a waste of your time. I'm so sorry, but I hope you learned something. Let's double check. I always like to run my programs frequently while I'm coding to make sure they're not broken, but also a couple times at the end to test if I could break them. Some jerk is always going to try to break your program, even if you don't know how to break it. So if I put gibberish here, sorry, wrong guess. Tree gets me out. That's great. Let's go do tree from the beginning, and we go straight to logins. Awesome. Okay. Thanks for watching. I'm going to get this back to its simple. No, I'm not going to help those. If you want the simple form, just rewind back before I put the guess variable in. But thanks for watching.